Hi, AB students. How are you? I hope you're having a good Wednesday or Thursday, depending on when you're listening to this. And let's review the last bit of what you're expected to know, Unit 7 and 8. That's the last part of Calc 1. So, Unit 7 is differential equations, um, and Unit 8 is applications of integration. They're going to leave off some of the integration applications. We'll talk more about that. But if this is going to be a cumulative review of Calc 1 and you're going to take Calc 2 in college, I want to make sure I cover all my bases. So besides preparing you for the AP test, I also want to make sure that you have reviewed all your Calc 1 ideas. So here we go. This handout was online. I hope you have it. Otherwise, take notes on your own paper and send it in. I expect you to do the problems on your own, then listen to the answer and make corrections in ink as you go. It doesn't do you any good to do the problems wrong. So, all right, here we go. Differential equations, big ideas. So first of all, differential equations are any time you're involving differentials, so like dy dx, but sometimes books use y prime, in which case when you go to separate the variables, the first thing you're going to do is write it as a differential equation. So a differential equation is anything with a dy or dx in it or a derivative in it. And it might also have the original x and y variables in it too. So as far as modeling situations with differential equations, that's when you know the rate of change rather than the amount equation. And we'll talk more about a famous one or two of those in a sec, but come back to that. Verifying solutions for differential equations. Now that basically means prove the equation is true for the given y prime, y double. It's kind of like an identity in trig. We'll talk about that. That did not go well, but we'll practice that in a minute. Sketching slope fields, I would imagine that's a pretty good bet for the test, but then again, I don't know how kids with a computer would do that, so maybe not. Maybe that idea is not going to be likely on the AP test, but it is a very common idea to be able to sketch a slope field. And they do build off of it in Calc 2 when they do Euler's method. All right. Reasoning using slope fields, again, that would be the idea that based on the change you see in the slope fields represent possible solution curves, so you could make judgments about the curve. A purple box over here, Euler's method is a Calc 2 topic in the purple box, so don't worry about that. Finding general solutions using separation of variables. Gosh, it's so crucial that if you have a differential equation, that you separate the variables first. You've got to show that, and that, I mean, put y and dy on one side, x and dx on the other side, or whatever the case might be. That's got to be done first, all right? After that, you're going to integrate both sides. And when you do that, you have what's called the general solution, all right? Now, usually they'll give you an initial condition to find the plus c. When you integrate both sides, don't forget that when you go to integrate, if you get a natural log, don't forget the absolute value. Otherwise, you're going to be making the problem much simpler, which you don't get credit for then. All right. When you go to use the initial condition, it's best to put in the initial condition right away to find the c. And in differential equations, don't use this idea y initial plus a definite integral. On definite integral problems, that idea is out. Do not use that in differential equations. If you see a differential equation, use separation of variables. Do not use the fundamental theorem kind of approach. All right, use separation of variables, find the plus c. And also don't forget that sometimes when you get rid of the absolute value or get rid of a square, you'll get plus or minus, and you'll need to choose based on the initial condition. And then last but not least, exponential models with differential equations. You need to remember that a rate of change that is directly proportional to the amount, or maybe A prime equals Ka, or dA dt equals Ka. Those are all exponential growth, and they imply the exponential growth or decay equation, right? So make sure you remember that. That is a huge idea of differential equations. All right, so let's move on to some practice. Excuse me. Would you try this one? Pause the video, try this one, and we'll go over the answer in a minute, all right? Okay, your answer is C. C is the one that works. If you got C and you totally understand where that's coming from, great. Move on. Obviously, you'll have the work to justify it. If you did not get C or didn't know what to do, then let's talk about it here, all right? So I did not try and integrate that given equation. I tried to take derivatives to show which one will work. So this is what my work looked like. For this guy, I need y prime to plug into the model I'm looking for. So y prime would be 2x, yeah? So if I looked at this equation for this original function, then it would be x times 2x minus 3. In place of y, I could put x squared plus 2 and say, does this equal 6? And if you look at the x squareds, they need to zero out. They don't. 2x squared minus 3x squared is not zeroing out. So you get something that's not true. If you try this one, y prime equals 6x. So if you then plug into this formula, x times y prime is 6x minus 3 times y is 3x squared minus 2. Again, I want this to come out to be 6, but I am not seeing this come out to be 6. It's 6x squared minus 9x squared. Those do not go away, so that's not coming out to be 6. This one, y prime equals 10x. So this formula here would be x times 10x minus 3 times whatever we said y was, which was 5. Oops. It's a cube, sorry. 15x squared. This was not looking right. This is 15x squared. All right, so minus y is 5x squared minus 2. That is going to be 15x cubed. Jeez, I'm really having my issues. 15x cubed minus 15x cubed plus 6 equals 6. So that's the one that's true. All right. Now that you have a feel for that, try this one. You probably need to find y prime, and y double for each, and then put into the differential equation. Okay, my answer was B. I hope your answer was B as well. If it was B and you understood, then please move on. If it wasn't B, get out the red pen. Here we go. If this is the case, then the derivative is 0, the second derivative is 0, the third derivative is 0. And so if I plugged into this equation, I would get 0 plus 4 times 0 equals 0. That is true, which we're looking for the one that's not true here. That is true. So that's not the answer. This one, y prime, is negative 8 e to the negative 2x. Y double is positive 16 e to the negative 2x. And y triple is negative 32 e to the negative 2x. Now if I plug into a given differential equation, I get negative 32 e to the negative 2x for y triple plus 4 times y prime. That would be minus 32 e to the negative 2x. Now because they're both negative, they do not cancel out. So that is not coming out to be true, although the terms look so close, the signs don't work out. I wanted to be sure, and I verified the other two, and the other two were true, so it is B. All right. Which of the following is a solution to the differential equation? Now, I obviously stripped off the multiple choices to this, but just basically find the solution to the differential equation and solve for p, please, in your answer. Okay, my answer to this, I'm going to write it up here, is p equals 10 minus e to the log 6 minus t. If that's what you got, then feel free to move on. If it's not what you got, then let's talk, shall we? All right. So if I want the solution to a differential equation, that means you want to get rid of the derivative. When I get rid of the derivative in a differential equation, I have to do it by separation of variables. Now, that was usually pretty easy, but this time not so much. So how do you get the dp and p on one side? So I thought maybe I'll multiply by dt, but then that gives me a p dt. That's no good. So I thought I want the p over there. Now, if I want the p's and dp's together, I guess I could divide that whole thing over, dp over 10 minus p, and multiply the dt back, yeah? Quality use up time. I hope that you didn't just slap log of 10 minus p over there, because it's more complicated than that. It is a function within a function, and if you did u sub it, then you would get something like negative 1 over u du equals dt. So that's negative log of absolute value of u equals t plus c, and therefore negative log of 10 minus p equals t plus c. So that's a technique question. Did you u sub it correctly? Or did you at least interpret or consider the negative matters? You know, if it were 10 plus p, I could probably do that without u sub and it would have been fine. But 10 minus p, things are different. All right. If you put in the initial condition, then time is 0, p is 4, goes in. So I get negative log of 6, which at that point 6 is positive, so I can dump the absolute value equals to 0 plus c. So c is negative log of 6. That means then that this equation becomes negative log of the absolute value of 10 minus p equals t minus log of 6. And now the hard work of finding p. So let's go slowly. Let's get rid of the negative first. Log of absolute value of 10 minus p. If I divide by negative, every sign switches, so it's log of 6 minus t. If I then exponentiate to get rid of the absolute value, to get rid of the log, 10 minus p, absolute value is still there, is e to the log of 6 minus t. That actually could be changed algebraically, but I'm going to leave it. Get rid of the absolute value. It's 10 minus p could be either plus or minus e to the log of 6 minus t. If I then move the p over by adding it and subtract or add the e back, then I get p equals 10 plus or minus e to the log 6 minus t. Now that's not a single function, that's two functions, so I need to choose. And at time 0, this is supposed to come out to be 6. Well, if I plug in time 0, then I get 10 plus or minus e to the log of 6 needs to equal 4. Well, the only way that's going to happen is if it's 10 minus, and so we choose minus for that to happen. And that is our answer. Okay. All right, pause and try the last one. And then we'll check that. Okay. So for this one, I have v is 400 e to the negative 1/20th t. If you agree, then we're all good. If you disagree, then I guess we need to talk about it, all right? So, first of all, I read this with interest because that is a form of exponential growth differential equation. The rate of change is proportional to the amount. So right away, v is v initial e to the kt. All right. Now let's figure out the v initial and the k. Well, they give us v initial. The volume of the glacier is 400 cubic kilometers at time zero. So using the initial condition, I found one of the things I need. Now I need to find the k. At the moment when the volume is 300 cubic kilometers, the volume is decreasing at a rate of, so the question is, should I use this or this? Well, given that they give us a rate of change, it makes sense to use the differential equation, right? So the volume is decreasing. That's the rate of change is negative 15. When the volume is 400, 300, that implies that k is negative 1/20th. And plugging that in is where I got my final answer. All right. Finally, for differential equations, will you try the free response practice? And we'll go over it in a minute. Okay, so for the slope field, anytime x or y was 0, the slope was 0. So that's going to be slopes there. If they're on top of the axis, make sure they're heavy and dark. Those are all 0 slopes. And then you have a bunch of 1s. That's nice. Those are easy to deal with. So in this first quadrant, x and y are both positive, so the slope is positive 1. Second quadrant, negative x, positive y is negative 1. Third quadrant, negative x, negative y is positive 1. And fourth quadrant, positive x, negative y is negative 1. So I got this kind of an x and a plus kind of thing going on here. All right, for the second derivative, I found that the curves are all concave down in quadrant 4 with lots of evidence, obviously, to work with. So one of the skills you need to be able to do is take the derivative of a derivative for a differential equation. And so if I have, say I have dy dx is xy cubed. And to get the second derivative, I'm going to take the derivative with respect to x of both sides. That means I'm going to get the second derivative. And on the left, the right, I'm going to use a product rule. First stays the same. Derivative of y cubed with respect to x is 3y squared dy dx. Don't forget to use the chain rule. Plus, second stays the same. Derivative of the first. Now, if I then substitute dy dx in, then I get 3xy squared times the derivative of xy cubed plus y cubed, or 3x squared y to the 5th plus y cubed. Now let's talk signs in quadrant 4. Quadrant 4, x is positive, y is negative. So what would this look like? Well, 3xy to the x squared y to the 5th would be positive, positive, negative. So this first term would be negative. Y cubed would be negative. So overall, this would be negative. And because the second derivative is negative, the curve is concave down. Okay. And then finally, question C. All right, question C. My answer was y is negative 1 over root 5 minus x squared. Did you get it? I hope so. If not, then let's figure out where you went wrong here. All right. So the first thing you would do, I hope, is separate the variables, because if you didn't, they wouldn't even look at it. So dy and y cubed go together, and x and dx go together. We're going to integrate both sides. Be careful on the left that you use the power rule, not log. The antiderivative of y to the negative 3 is a power rule derivative. So when I integrate, I raise it a power, divide by the new power. So that's y to the negative 2 over 2 equals x squared over 2 plus c, or 1 over negative 2y squared equal x squared over 2 plus c. Now let's use the initial condition. If x is 2, y is negative 1 is used, then I get negative 1/2 equals 2 plus c. So c is negative 5/2. And therefore, my equation is now 1 over negative 2 y squared equals x squared over 2 minus 5/2. Now let's clean this up, because they do want you to solve for y. Right there's the implication there, solve for y. So let's say we move a negative 2 over. If I multiply both sides by negative 2, then I'm going to get a 1 over y squared, and over here I'm going to change signs and cancel out the 2, so it'll become 5 minus x squared, yeah? If I take reciprocals of both sides, when you take reciprocals, it's reciprocals of a whole side at a time, not term by term. So it's not 1/5 minus 1. It is 1 over 5 minus x squared, and they're not the same. And then y is plus or minus 1 over the square root of 5 minus x squared, and I need to choose. Based on the fact when x is 2, y is negative 1, I need to choose the negative. So y is negative 1 over root 5 minus x squared. All right, how'd that go? I hope you were successful. Let's go and switch directions to applications of integration. Here we go. So again, not all of these are going to be on the test, because they're assuming that once social distancing happening or school shutting down happened, you didn't get to the end of the rubric. We obviously at Saxon do things differently, so we have done big chunks of these, but just do things well here, all right? So as the next couple days goes on, we'll look again at the syllabus, what they're going to put on the exam. We'll do mixed practice Thursday and Friday, all right? So finding the average value of a function on the interval, you hopefully remember that the average value, average y value, is 1 over b minus a, from a to b, of the function. Please, I beg you, read carefully for average value versus average rate of change. People get those confused. When it's average value of a function, we do this integral idea. Average rate of change is more like a ratio or rate of change, all right? So keep those clear in your mind. Let's talk all the different motion ideas. I think you know that velocity is the antiderivative of acceleration. And use the initial to find the plus c. As far as position goes, the integral velocity is displacement or change in position. Absolute value is distance. And if you want, now that's change in position is displacement. If you want position at time, then you would say, what is the initial position plus the change in position up to a point? Okay, so remember, the integral alone is just displacement. If you want position, you need to consider what was the original position and the change too. All right, and that's pretty much what I wanted to say. Remember, speed is the absolute value of velocity. Accumulations, so applied context, remember, just basically integrating a rate of change gives you amount of change. So, for example, if you've had a rate at which a radius of a tree changes, then by integrating it and using the fundamental theorem, you'd talk the change in the radius, yeah? Find the area. Okay, just remember that, when you do area, integrals are rectangles, and if the rectangles go this way, then they'll use x, and if they go this way, then they use y. All right, so you choose based on, what's easier to integrate and how many regions of each, so that all goes into your choices. Make sure you consider all your choices and know whether you're using x or y. Sure sign of somebody that doesn't know what they're doing is using the wrong variable. Area between two curves intersect at more than 2 points. Just remember, the area should be positive. If you use right minus left and upper minus lower, you'll get positive lengths of rectangles and therefore get positive volume. All right. Draw pictures for Pete's sake. For all these cross sections, the volume is the sum of many prisms. The height is either dx or dy, depending on if they say the cross sections are parallel or perpendicular to this axis or that axis. Now, unlike areas, those are not your choice. It comes from the question, so you don't have choices there. You have to draw a picture and figure out, all right, this means I'm using x, or this means I'm using y. The area of the base could be lots of things. It could be a side squared if it's a square, base times height if it's a rectangle, root 3 over 4 times the side squared if it's an equilateral triangle, or pi over 8 times the diameter squared if it's semicircles, depending on the case. Notice in these volumes of revolution that it's disks and washers. Shells are never required on the AP test, but they can be used, and actually it's sometimes the case that they're easier to use than the other. So you can use shells, but any problem you get could be done with discs or washers. All right. Draw a picture, and again, right minus left, upper minus lower to get positives. All right, so let's practice. Start with this question here. You may use a calculator. It's kind of wacky, but you'll get it if you think your way through it. Okay, so the answer was A. If you got A and you feel like you know what you're doing, cool. It wasn't an easy question, so you might want to talk about it. Now, first thing is the calculator does graph relations, which is to say non-functions, but a lot of the intersections and other stuff that goes with your functions are disabled. So I didn't actually use my calculator that way. I said more like, all right, it's first quadrant. Left is y to the fourth plus y squared, whatever that looks like. And right is 5y, which is a line. I don't know why I drew it like that, but whatever. It's supposed to be first quadrant too. So I know that if these are y equations, I'm probably going to be using y. So I'm probably going to be doing something like 5y right minus y to the fourth plus y squared left, and dy is the height of the rectangles. The only question is the intersections. Well, we need to set the two equations equal to each other. 5y equals y to the fourth plus y squared. 0 equals, when you move the y's over, you get this kind of deal, y cubed plus y minus 5. At that point, then I saw those decimals. I thought, okay, this must be calculator. Now, obviously, 0 is one intersection point. Again, I apologize. My picture's terrible, but this, where this is 0, I had no idea. And so I used my calculator to find that. I actually just graphed normal y equals x cubed plus y minus 5 plus x minus 5 and found the 0 in a normal calculator kind of way. And I had 1.515. Then I threw the integral into my calculator. All right, let's go to the next one. If you haven't tried it already, try it and pause the video. Okay, the answer is D, 68. If you got D and you understood, cool, move on. If not, then let's talk about it, shall we? All right. So the average value of a function is 3. What's the value of that thing? So I started at the question. I said, all right, I know by integral rules, the 5 I could bring out front, and I could split the 2 off into its own. And this I can integrate and actually find. This, without knowing f, I don't know. Well, that's where the average value idea must come in. The average value is 3, so 3 is what we get when we do the average value calculation. That implies then that if I move over this 4, that the integral must be 12. And so if this is 12, then it's 5 times 12. That whole thing is 12. Plus, and this I actually do have to integrate. People tend to blow that off and they lose the answer because of that. 60 plus 12 minus 4, so 68. All right, let's move along. This one's a good one. All right, try this. Sorry, the answers in terms of trying to get this on less pages to save your printer and copier charges. Let's look at that. The question that was down here. Okay, my answer was B. B. Did you get B? If not, then let's talk about it here. So if this is motion, then where V is positive, this is forward movement. And these two are backward movement, yeah? When V is negative. So they tell you the displacement is 15 and the particle travels a total distance of 73. What's the total distance the particle travels while moving to the left? All right, so let's actually call this moving right here. This is moving left. All right. Okay, so if the total distance is 73, then doesn't that mean that the right area plus the left area equals 73? And I'm talking area just without signs. So those two added equals 73. The displacement is 15, so that means the right take away the left is 15. Now, if I solve the system by, let's just go elimination, 2r equals, 88? So r is 44. That's cool, but they said moving left, so I need to go back and find left. So if 44 plus L equals 73, then L is 73 minus 44, so that is 29. All right, cool. Last but not least, free response. Try the free response. I hope I didn't make that too small, but it's basically a piecewise of two parabolas put together, and you're doing lots of different things there. So go. Okay, let's check your answer. So my answer to this guy is 2. That's not very visible, sorry. This is 2. This is an integral expression. It's actually 2 integrals. And then this, actually, I might as well just say that. So this is from 0 to 1. It's 2 minus x squared, plus from 1 to 2, it's x minus 2 squared, so to the 4th. That was my answer there. And for the last one, I have, that one killed me. I had to fight it out between two methods, and I decided on 5 pi over 6 as the volume. All right. So let's go, shall we? If you did well, then I guess you're done in 37 minutes. If not, then get out your red pen and let's move on and correct it. So let's start with the area. I would strongly recommend, because these are squared and you don't want to do plus or minus, that you use x. And there are 4 rectangles that go this way. But if it's piecewise, you have to do that in 2 pieces. So you should be doing 0 to 1 of 2 minus x squared for the height times dx for the base, plus 1 to 2 of x squared minus 4x plus 4. I guess I could have left that x minus 2 squared and called it. I guess I didn't need to do that, but safe. All right, so let's integrate. This first antiderivative is 2x minus x cubed over 3 from 0 to 1. This next is x cubed over 3 minus 4x squared over 2, so 2x squared plus 4x from 1 to 2. The first one, when I put in 1, I get 2 minus 1/3. When I put in 0, I get 0. Next integral, when I put in 2, I get 8/3 minus 8 plus 8. Minus, when I put in 1, I get 1/3 minus 2 plus 4. All right. So all together then, let's do all the whole numbers. I have 2. These cancel out. And this is 2. 2 minus 2 is 0. this is not coming out like I thought it would. 2 minus 2. I guess that it's 0. Negative 1/3 then, minus 8/3. Negative 1/3 plus 8/3 minus 1/3 is 8/3 minus 2/3, or 6/3, or 2. Okay, I did it slightly differently than the first time I did it, but it is what it is. This one, if you're not sure where I came from there, again, when you use piecewise, you have to use two integrals. If the cross sections are perpendicular to the x-axis, they go this way. That means then that they are dx thick, so you have to use x. And as far as the area of the base, it's going to be side squared. So this first region, it's 2 minus x squared, all squared. And the second region, it's x minus 2 squared, all squared. No pi's there, please. All right. And then finally, the last one. So I don't know how you did this, but if you did shells, it was much easier. If you did washers, then you probably had a problem. I did both just to make sure I had time, and I verified they were the same. They weren't the same, and I was freaking out. And I checked the AP rubric or the AP classroom, and they had a mistake. Guaranteed, no doubt about it. They have a mistake going. And so there's a good lesson to be learned here. So here's the deal. If I take, now I've got this part here, this downward opening parabola, but the part we're interested in is this part here. We're revolving it around the y-axis, and we're getting this volume of revolution. Now, if we use x, then our rectangles will go this way. If we revolve those rectangles, then we get a cylindrical shell. Volume then is 2 pi times the radius times the height times the thickness, which is dx. The radius is x. The height is the function that we use from 1 to 2, which is x minus 2 squared from 1 to 2 in x. If you clean your integrand up first, you'd get x squared minus 4x plus 4, but then multiplying by an x, so x cubed minus 4x squared plus 4x. All right, the antiderivative then is x to the 4th over 4 minus 4/3 x cubed plus 2x squared from 1 to 2. And when you evaluate that cleanly, you get 5 pi over 6. So if you did y, then you might have had something like 37 pi over 6 instead of 5 pi over 6. So you might ask, what happened? Did you break math? And the answer is no. Math is fine. You just didn't execute it well. So let's go with y. If you do y, then you're doing slices like this. And you're going to get a washer. Volume is pi. Now the limits go low to high, so they're 0 to 1. And the problem is big R. And the height is dy. Now big R is the distance to the curve, right? So if we take y is x minus 2 all squared and put it in x, solve it for x in terms of y, then the first thing we have to do is square root. And when you square root, good math says it's plus or minus. So the question is it 2 plus or minus root y? Now, if you use 2 plus root y, I guarantee you got the wrong answer. And that's because that is what you'd use for this part of the parabola, not this part. If you use the part that passes through 1, 1, well, 2 plus root y, that does not pass through 1, 1. It's got to be 2 minus root y. So if you used washers, then you must have used 2 minus root y, and then little r is 1. And integrate that, well, that gets you 5 pi over 6. All right, that is pretty much it on all the review of the material. Tomorrow we'll start doing mixed practice, and I hope you have a great day. Sorry about the delay in getting the test graded. I will try and have them graded today so you know where you're at. Goodbye. Maybe.